Alright, let's talk about generics. Now, first of all, why do we want them? One of the ideologies of programming is to not reinvent the wheel, to minimize the amount of code that you need to write. And we already do this in a few ways, by writing methods, by importing libraries which already have a lot of stuff predefined, and by using inheritance in object-oriented programming. In Java, when we declare a method or a variable, they are tied to the types that are used. This is where generics come in. You could see it as a way of writing a template, so that you can just put in the right types when you need to. This is a really great way for us to minimize the amount of code that we write and to generalize our programming. So in this first example, it's a very simple program that just prints out the integers that are held in an array. Now this syntax may be new. It's called a for each loop. The way that you read this is for each integer named val in array. Basically the way this works is that we specify the type that's in the array. So we have an integer array, we say int. We specify a name that we want to refer to all the values inside by, and we tell it where to get that data from. So this works much like a for int I equals 0, etc. loop, where you would access array at element I. But for this one, we just let it take care of that stuff for us. It will go from start to finish of that array, and at every time through the loop, we can refer to the current value as val. So what this program will do right now is print out the numbers 1, 2, and 3 on separate lines. But what happens when we also want to do this for doubles? The way that we know so far is to overload the method, write another one which takes a double, and goes through the collection of doubles. Notice that the only difference that there is between this and this is that the top one has int, this one has double. Besides that, everything is exactly the same. So now the integers call this one and the doubles call this one. What if we want to extend that to also people? So we have a class written somewhere else called person. And I want to write a method that will print out all of the people in that array. So I create my person array and I call this method. Again, the only thing that's changed is instead of double or int here, we have person and person here as well. So this is where generics come in. If we can determine for any method or any class which is the data type that will change, then we're already halfway there. So let's just make this seem a little bit more generic by, instead of writing int, double, and person, we'll instead write t, which means type. So all we've done different is, instead of writing int brackets array and then for int val, we just write t and t. And this is basically a placeholder, so that when we do call the method, Java will infer the type that we want to work with. Notice also that I've had to put this t in angle brackets out the front. If we were to not include this angle bracket t and just put t array, Java would think that this must be the name of a class and would try to find it. We must put this at the start to tell it that the t is to be used as a generic placeholder for some data type. One other thing to notice is that instead of before, up the top, we had int, double, and person, written just like that. Now we have to write integer, double, and person, all with capital letters. The reason for this is a bit of a tricky one, but in Java generics we can't use a native type like an int or a char. We always have to use their class equivalent. Java provides an integer class, a double class, a float class, and so on. We have to use that, but they work basically the same. So let's have a look now at generic classes. This is the node class that we used when we wrote our linked list class in the previous video. So if we were to change this to be a generic class, the key is to find what data type will change. So we know that for any node, it will always point to another node, so that won't change. So that means that when we get that node or we set that node, it'll always be returning something of the same type, because the idea of a linked list is that it points to its own type. So if this is a node, this should also be a node. So that means next will not be changing. The thing that will change is our data. I said earlier that a linked list that can only hold integers is not a very good linked list. So if we could make that integer part generic, then we can store whatever we want in there. This is what we'll do. So see that I've replaced the word integer with e in all of these places. So instead of having int data, it's now e data. And instead of public int get data, it's e. And the same goes for the set. Just like with the method, how we had to use the angle brackets t before to tell it that the t is a placeholder for some generic data type, we have to do the same in the class by writing e. This means private e data is not a class called E, it's a placeholder. And now because I have node and then E in angle brackets here, that means that any reference to a class like this, to the node class, needs to give a type in brackets. So when I create a new object, if I want to store, say, a string in this node, I would create that by putting string in the place of E. Node string equals new node. And that means that inside that instance of this class, any reference to E that we see is now referring to string. So I'm saying that a private node, this next, is a node which holds a string inside, or a node that's been templated with a string. So here with getNext, when I return my next, the data type is node E, which means that my method signature must be public node E, getNext. The same with setNext. I need to take a node E as the parameter, not just a node now. Let's have a look at the linked list class. This one gets a little bit trickier. As I said before, you need to think about which data type will change. So in this one, we just saw that our node will now have an E on the end. And when we insert a new value, we don't have an integer anymore, we'll have some generic data type. So let's have a look. Now we have insert at front E data, just like we expected. But there's something a bit interesting happening up here, where we have E extends comparable E. I'll show you the details of this in just a minute, but the important thing is that in part of our code, in our original linked list class, we used the less than operator. Is one less than the other? That was okay because we had integers, but if I put two strings in and I try to compare them using less than, it won't work. So now we need to do it in a slightly different way. The way that we would compare strings is by using compare to. Now that compare to is part of the comparable interface. But if we wish to use compare to on any of the data that's put into this linked list, we need to enforce that, because otherwise someone could create a linked list with their own person class which may not have the compare to method. And if that's the case, the program just won't be able to compile. So we enforce this by saying the data type that gets given to us, which we'll call E, extends the comparable interface. The comparable interface is also generic, so you just have to specify that the class we're passing in extends the comparable interface and will be compared with something of the same type, E. Writing that E extends comparable E means that if I try to instantiate an object of this linked list with a data type that doesn't have the comparable interface, it just won't compile. This is our way of enforcing the rule that we need to have the compare to method. So, as we saw, node always now has angle brackets E after that, meaning it's templated with whatever this value here is. And our public void insert at front now takes some E data, just like we saw with the node class. So here we see our first constructor involving a generic type. As I said before, whenever we refer to the class, we have to write these angle brackets E on the end, or angle brackets something. So here we've said node angle brackets E, new node. And that just says the data type is the same as this linked list holds. And now we call the constructor new node data. So this constructor is exactly the same, with the exception that we have these little extra angle brackets on top. It depends on the compiler you have, but in some versions you may have to write E or whatever data type you've put here in between these angle brackets. In a lot of cases you don't need to. The next two lines after that are exactly the same. So let's see insert at end. We've already got through insert at front. This one will be mostly the same. So instead of taking in int data, we'll take in E data, correct. And instead of having node new node, we'll have node E new node. Beautiful. So here we have it, E data, node E new node, and new node open close angle brackets data. It's the same as we saw in the last method. And we have one more node variable that we declare, which is here. And because we're not calling the constructor, nothing special has to happen on the right hand side. We just say put head into here, and of course the type is still node E. So for insert in order, it's all much the same except with one difference. So again, we've replaced int data with E data, and node with node E, new node data with new node angle brackets data. That changes exactly what we saw in the last one, it's consistent. The big one that's changed here is that before we had is data less than head.getData. Now we can't use the less than, we have to use this compare to. This is why we enforce the rule that they need to be part of the comparable interface. Let's assume for a moment that this linked list was created with strings. That means that this E will be string, and this node E will be node string. So we have a string called data, and we have a node containing a string. If I had the previous code, which was data less than head.getData, this would be string less than string, which doesn't work. For strings, we have to use the compare_to method. And this is a consistent interface that should be implemented in anything that goes into a generic class like this. If we were to do the same thing with a person class that we've written, we need to make sure that we implement the comparable interface. And that way, this compare_to method will be defined for people as well. So we can't use a less than. If we were to not change it, if we left our code the same as this, it wouldn't compile. And the same thing happens down here. It makes this actually into quite a long condition. Before it was data greater than p.getNext.getData. That was long enough. Now it's data.compare_to p.getNext.getData greater than 0. So it is a bit longer, but the way that I like to think about these compare_to methods is if I'm doing greater than 0, you can kind of imagine that you throw away that 0 and put the greater than where the compare_to is. So data.compare_to all of this is equivalent to saying data greater than all of this. If this were a less than symbol, it would be like saying data less than all of this. And finally, we'll have a look at the search method. This one was one of the easier ones again. Of course, we have to replace int with e and node with node e, which we've done. Int with e, node with node e. As I said earlier, whenever we refer to that node class, we have to give it a type in brackets. So because this returns a node, we must put angle brackets e on the end to say that the node that it returns uses the same data type as the linked list which we're inside. So as we saw from that first example, where we wanted to print out the items in an array, we saw that we didn't have to tell that method what type we were passing in. It was able to figure it out. It could understand based on what we were giving to it. Generic classes can't do this. We always need to explicitly tell the class which type it will hold. So we can see here, when I create a linked list of integers, I need to tell it that it is a linked list of integers because it has no other information. If this part weren't included, the integer part, there will be nothing here to say that this list holds integers. Similarly, we have to write person here to tell it that it holds people.